Welcome. This program will calculate student grades based on the first three assessments for CSC 171, Homework 1, Homework 2, and the required algorithm forum. This program will demonstrate the use of list and list operations, how to format for percentages, and a sneak peek ahead at an upcoming topic on decisions using if-else. So the first thing this program does is to declare a student grade list. Notice the use of the square brackets. This symbol indicates that we will be working with a list data structure. The input section of the program asks the user to enter their name, their Homework 1 grade, their Homework 2 grade, and their grade for the Algorithms Forum. It then stores Homework 1 grade, Homework 2 grade, and the Algorithm Forum grade inside the student grade list. Next, we ask for the user to enter the possible number of points so that we can calculate the current semester average. In the process section, we compute the average by adding together the three assessments and then dividing by the possible points. We then append that average to the student grade list using the append method. The output section inserts to the list the user's name, which was stored in variable myname at location 0. So we're putting the name in to be the first item in the list. Then we print out the name, Homework 1 grade, Homework 2 grade, the algorithm grade, and the student's average. Let's run the program, and then we will inspect a few items in the program. And Eileen Dover's Homework 1 grade was pretty darn good. It's a 9.2. Homework 2 was an 8.6. And the required algorithm forum grade was 6.2. The total possible points was 27. And we see here that Eileen Dover average was 88.9. And this program prints a message out for her to keep up the good work. Now let's arrange that output next to the program and see which lines of code produced each one of those lines of output. After creating our empty student grade list, we captured the inputs of the name, Homework 1, Homework 2, and the grade for the required algorithm forum. Then we loaded those values into our student grade list. Now remember that a list is mutable. Therefore, the empty list is now replaced with the entries Homework 1 grade, in this case 9.2, Homework 2 grade 8.6, and the algorithm forum grade of 6.2. We then ask the user to enter the total number of possible points so that we can compute the average. The total possible points for those first three assessments was 27. We computed the average of those first three assessment grades by adding them together and dividing by the possible points. And then we added the average to the student grade list. So when we use the .append, it adds the average to the back of the student grade list. A little bit further down, we see student grade.insert. Using the insert function, we can designate where we want something added into the list. And in this case, we said at location 0, so the individual's name, Eileen Dover, was added to our student list in position 0, which means that all the other items had to shift down one place. So Homework 1 that was originally in location 0 is now in location 1. Homework 2 has moved from location 1 to location 2, and the algorithm forum grade is now in location 3. The average is in location 4. So we have 5 items in the student grade list, and they're numbered 0 through 4. Let's look at the average print feature. Here we're using the percent formatting so that the student grade sub 4, which is the average, is presented in a average amount based on 100%. So although this value is stored as 0.889, when we format it using the percent, it comes out looking as a percentage based on 100. Finally, we have a peek ahead at Chapter 3 topics on making decisions, and we check if the average, which was student grade sub 4, is greater than 0.75. We provide a motivating assessment here for the student to keep up the good work. But if it's not greater than 75%, then we ask the student to work a little harder. In the center section of the program, there's a message where you should uncomment the prints to see what is stored in the student grade list. So I'm going to uncomment those, and then we'll run this again. So we're going to have a little bit more information provided, but it allows us to see how Python works on the entire list. Let's run the program again. Now remember, we made changes by uncommenting those statements, so Python's going to ask us to save it again. I'll say OK. This time we have Pete Moss, and Pete Moss hasn't been keeping up, so let's give him some not so great grades here. Homework grade 1, 5.2, homework grade 2, 6.8, and his required algorithm, a 5. Still 27 points. And now we see a little bit more output here based on those print statements so that we can see exactly what is stored in the student grade list. So after building our student grade list with the 3 scores and the average, we see that we have 5.2, 6.8, 5.0, and there's that average that has not been multiplied by 100 of a 62%, 62.96%. Notice that without formatting, we've got a pretty ugly looking number there. And then we added the name to the front of the list with the insert function. So now we see that Pete Moss is the first entry in the list, followed by homework 1, homework 2, the required algorithm, and finally the average. It's a little bit off the screen there, but the important point to note here is that Pete Moss has been added to the front of the list. Then when we print each individual item, we see the average looks a lot neater. Using the print format, 0.6296 comes out as 63%. And finally, we see the message that with the 63% average, we print the message, you need to work a little harder. Review Chapter 2 for lists and some of the features that are provided with lists, where we can add to the back end of the list using append, assign values directly to a list, and insert into any location in the list where we want to add an item, and the subsequent items will all move down one place. Happy Python coding!